K. Viswanath Allamraju, Institute of Aeronautical Engineering, Department of Mechanical Engineering, Dundigal, Hyderabad. Today we are going to discuss about the introduction of the CAMs. What is CAM? What is CAM profile? What is the terminology are going to be used in CAM profiles? And what are the types of followers? What are the types of CAMs? And we are going to study in briefly. So a CAM is nothing but a mechanical member used to import a desired motion to followers by direct contact. The CAM may be rotating or reciprocating, whereas the follower may be rotating or reciprocating or oscillating. So very important is that a CAM is also used for converting the rotary motion to reciprocatory motion of followers in the case of a 4-stroke IC engine. How it will be converted? In the case of 4-stroke IC engine, there will be a shaft that is called cam shaft. This cam shaft, what it does? This cam shaft, on the cam shaft, there will be cams. Cams will be there. These cams are in contact with the rocker arm mechanism and followers are connected to rocker arm mechanism, and rocker arm mechanism is connected to valves. Those valves are useful for opening and closing such a way that to transfer the air fuel mixture into the cylinder. So a cam and follower followers contact between them. Contact is a point contact. A point contact. So if there is a point contact between two links, cams, either cam or follower, between the two links, cam and follower, that contact related to the pairs are known as higher pairs. That's why cam and the follower combination belong to the category of higher pairs. Necessary elements of a cam mechanism are, here it is mentioned, a cam and the follower, called the follower here. So a driver member known as the cam, a driven member is known as the follower. So here why we are going to study this, these cams, what is the use of these cams? So these are how, in what place it will be manufactured, what are the procedures will be followed to manufacture the cams. The cams are usually manufactured by die casting or milling or by punching presses. These are the different fabrication processes to manufacture cams. Now, one more thing. Complicated output motions are very important word here. In order to achieve if you want to achieve complicated output motions, a difficult to achieve can very easily be produced with the help of these cams. We will discuss in the next slide what is this complicated output motion. The complicated output motion means that simultaneously mechanism, suppose in slider crank mechanism, when crank is rotating, the slider can be sliding within the cylinder. But in the cylinder, if you want to open, suppose if you want, there are valves are attached. If you want to opening and closing requirement is there, valves requirement is there. In order to send the air fuel mixture into the cylinder, that mechanism from the crank via gears it can be transmitted. How can we transfer it? This walls should be open. At the same time, the crank rotational power, the torque should be used to open the valves, for opening the closing of the valves. How to use it? The mechanism we will use in order to for opening the closing of the valves from the crankshaft with the help of camshaft. The crankshaft and camshaft are connected through gears, worm gears. So through this worm gears, the camshaft is attached to the crankshaft. Then camshaft will be rotated. When the valves, the rocker mechanism is such a way that it is in touch with the cams. So this type of motions can be replaced. If you want to replace such type of motions, these cams will be used. That's why complicated output motions requirement, wherever requirement is there, these cams, with the help of cams, we can produce them. Okay, and where it will be used? Cams are widely used, very important. Cams are widely used in automatic machines. As I mentioned here, internal 4-stroke engine, that is internal combustion engines, and machine tools, printing control mechanism, and so on. So cams are so important. For printing control mechanism is a different topic, and machine tools is again, and internal combustion engines. So completely, so these cams comes under the category of higher pairs, but not in lower pairs. That is very important. So one more thing, we are going to study in this module. It comes under module 4. Module 4, not only introduction of the cams, we'll study how to draw the cam profiles. What is the shape of the cam based on the output parameters, based on the input parameters. Suppose the follower based on the driven motion, what is the driven member? If the follower is rotating or moving with uniform velocity or uniform acceleration or simple harmonic motion, based on the driven member motion, what is the design? What is this design of the cam? That design of the cam comes under the category of synthesis of cam. So we'll study very briefly in this module. Yes. Now, here we can see the cams are classified according to the shape. The cams are classified according to the shape, and also follower movement, and third category is manner of constraint of the follower. There are different categories are there. 3 categories. Similarly, as we have studied classification of kinematic pairs, the kinematic pairs are classified based on point, nature of contact, nature of mechanical constraint, and nature of relative motion between the links. Similarly, in the case of cams also, based on the geometry and based on the follower movement and manner of constraint of the follower. Now, according to based on the shape, this is wedge and flat cams. This wedge and flat cams, if you observe here in the figure A, B, C, wedge and flat cams, but the followers here, it is in this case the follower is a knife edge follower. It is a knife edge follower. Here it is the roller follower, and here it is also same as knife edge follower. Okay, these are the different based on the shape. So a wedge here, very important. The motion of the wedge is also cam, based on the cam, wedge cam, we'll call it wedge or flat cam. So here this wedge cam, if you see it, the motion of the wedge, a wedge cam has a wedge, that is W, here wedge is there. The wedge having in the motion is a translational motion. Translational motion. When translation is motion taking place, the follower is the F can having a motion that is up and down motion, that is also translation, vertical translation motion. It will be the follower is in contact with the wedge, is a point contact. It comes under the category of higher pairs. This contact can be taken place with the help of a spring which is attached here. The spring is having a elastic property such a way that it makes the follower to keep in touch with the wedge always. Now, again, in the case of classification of kinematic pair, if you see there is nature of mechanical constraint. Under the nature of mechanical constraint category, there are two types are there. Number one, closed pair. Number two, open pair or unclosed pair. This type of pair comes under the category of unclosed pair. In unclosed pair, what will happen? The follower is always in touch with the cam's surface, either due to gravity or due to some spring force. Here, due to spring, that is elastic element, is making the follower is to always keep in touch with the wedge. Okay. Then what will happen? When this wedge is moving towards right side, then what will happen? This follower will rise upwards in y direction. Upwards, positive y direction. When wedge is moving towards left, then the follower, what will happen? Towards left. Okay, no. When the wedge is moving towards right, this follower will goes down. Then what will happen? It will be negative y direction. Downwards it comes. It will be in downward direction. When the wedge is moving, what will happen? When the wedge is moving towards left direction, towards left means this direction. When wedge is moving towards left direction, the follower will be in positive y direction. Okay. Thus, what will happen? The horizontal translation motion of a wedge is converted into vertical translation motion of a follower. That is the meaning here. That is the figure A. And in the case of figure B, what will happen? Here the wedge is designed such a way that, with some curvature, non-linearity, it is not in linear. Whereas the wedge shape here, the wedge is in linear, here non-linear. So, but the follower is the roller follower. What will happen? It converts translatory motion of horizontal translatory motion into what will happen? The rotary motion of the shaft. Thus, we can convert the translatory motion into rotary motion. Again, in this case, in this figure B, 7.1b also, the follower is always in touch with the wedge of the cam with the help of a spring. The spring elastic element makes these two elements, the follower and cam, always in contact each other. Such a way the motion can be transmitted from one link to another link, from one element to another element, from wedge cam to follower, from cam to follower can be transmitted when only in touch with that. As we can see, when our finger is in touch with the fire, then only the fire can burn. Otherwise, if it is away from that, there is no transmission of the fire energy to your body. Similarly, you hear transmission means always the links should be in contact. That contact can be taken place here in this case with the help of elastic element that is known as spring. Here we are going to use it. Now next one. Coming to figure C, here there is, we are going to mention here wedge. Wedge here in this case, if you observe figure A and figure C, there is differences there. In figure A, the supports, guided supports remains fixed. Whereas in the case of this figure C, the guided ways are not remains fixed. It is free. Now we can see what figure C explains. The figure C explains here the cam is stationary and the follower constraint or guide G causes the relative motion of the cam and the follower. Again, once again, the cam is stationary. In this, the cam is not movable. The cam is stationary. When the cam is stationary, the follower has to move from this portion to this portion. What will happen? This guided ways pushes it is. So the vertical translation motion is converted into the horizontal translation motion of the cam. Whereas in the case of figure A, the wedge is not fixed. It is moving. Now at that time, but guides G are fixed. Thus it is up and down motion, horizontal and vertical. Now whereas in this case, wedges remains fixed. That's why all these figures. Now instead of a wedge, one more thing, based on the shape, instead of using a wedge, a flat plate with a groove can also be used in order to transmit a horizontal translatory motion into a vertical translatory motion of the follower. So these are the different types. But in this case, no need to use a spring. Why no need to use spring? Because this follower remains within the groove of a plate. So thus, we can replace one element by another elements in order to achieve various motions, output motions. Now what is the driver here? The driver is wedge with a groove. The follower is here F is the follower. The follower is the driven member. Now coming point here. In the case of figure A, the driver is wedge cam. The follower is a driven member. In the case of figure B, the driver member is wedge cam. The follower member is, the driven member is the follower. In the case of figure C, the driver member is follower. The driven members are guides. Now, second category of the cams. The second category of the cams are radial or disc cams. Very important. Radial or disc cams. This figure B comes under the category of, in the case of classification of kinematic pairs, it comes under the category of closed pair. Based on nature of mechanical constraint. Based on nature of mechanical constraint, this is completely closed. The cam is completely closed with the closed follower. It can be, the transmission can be stopped when one of the link, either cam or closed follower is broken. Then the transmission will be distracted or disturbed. Now let us begin. A cam, let us read systematically word by word, such a way that you can understand when you open the textbook better. Now, a cam in which the follower moves. The cam in which the follower moves radially from the center of rotation of the cam. Radially it moves. A cam in which the follower moves radially from the center of rotation of the cam is known as a radial cam or a disc cam. This is a radial cams. The radial cams, what are the shapes of radial cams? It can be elliptical shape or oval shape, or it can become a circular shape. Now, but radial cams are very popular due to their simplicity and compactness. The design is simple. Design to manufacture radial cams are easy. Now, that's why it here, how can we call it as, why should we call it these cams or radial cams or disc cams? Because the follower moves radially from the center of rotation of the cam. That's why these cams are known as a radial or a disc cam. Radial cams are very, very popular due to their what? Simplicity in design. So again, there are two figures are there. Category A, figure A and figure B comes under the category of radial cams. Now, one more important. The contact, what is the driven member in these two figures? The driver member is the cam and the driven member is the follower. The follower is the driven member. And what is the cam? The cam is driver member. The contact between the driver and the driven member is the point contact. That's why it comes under the category of higher pace. Now, it is also higher pace. It is the double point contact. The point contact, if it is circular disc, the point that also the closure pairs also comes under the category of here higher pair. Okay, thus we can understand what is a higher pair and closed pairs, higher pairs. Okay, now what is the third category? The third category of the cams are spiral cams. Okay, let us read word by word sentences from this slide. A spiral cam is a face cam in which the groove is cut in the form of a spiral. A groove is cut in the form of a spiral. A groove is cut in the form of a spiral. So the spiral groove, what will happen when it is rotating? The spiral groove consists of teeth which mesh with the spin gear follower. The gear connection will be there. When it is started rotating, what will happen? The gears start based on the cam. The gear is always in contact with the spiral groove. So whatever spiral, here the spiral groove guides the motion of the follower. So if the spiral groove is exactly circular shape, then there is no vertical translatory motion to the follower. The spiral groove is the radius. The radius of the spiral groove is not constant. It is variable. That's why here the follower, when the follower is always in touch with the groove of the cam, the groove is such a way that based on the groove, the motion of the follower depends. So the motion of the follower is dependent on the shape of the spiral groove. Now, the spiral groove consists of teeth which mesh with a pin gear follower. The velocity of the follower is proportional to the radial distance of the groove from the axis of the cam. Okay, what is the groove? It depends radius of the groove. The motion of the follower is dependent on the shape of the groove. Okay, what is the use? The use of this such type of cams are very limited. Okay, so especially this type of cams and followers, we can find its use in the case of computers. Okay, the computers are completely designed by the mechanical engineers. Okay, but the program is coding designed by the computer. Okay, program code is given by the computers, but the part, the structure is completely designed by the mechanical engineers. Okay, either it may be a plastic material or it can be different metals. But all the things are completely fabricated by mechanical engineers. In that, if you want to transfer where it will be used, if you open the laptop in the CPU portion, there you can find out very small. It is not this much big size, will not be there. So we can use finding the use of this type of cam. Now, fourth category is cylindrical cams. The cylindrical cams, in a cylindrical cam, what will happen? Which has a circumferential contour cut in the surface, rotates about the axis. So the first type, a groove is cut on the surface. Okay, a groove is cut on the surface of the cam, and a roller follower has a constrained oscillating motion. We can see here the cylindrical followers, the cylindrical cams are here. It's not a division types of followers we are studying here. Here we are studying only types of cams. So is the cylindrical cam, the geometry of the cylindrical cam, you can see is a cylinder shape. On the surface of the cylinder, it is made a groove. So when the cylindrical cam is rotating under rotary motion, what will happen? The follower also, what is the types of the motion? It depends upon the follower motion is dependent on the groove on the surface of the cam. Similarly, this is another cam. How it will be? When it is rotating, it is reciprocates horizontal translatory motion. But in this case, the cam is always in touch with the groove of the cylinder with the help of elastic element. Okay. So it is called a spring loaded. We can see a spring loaded follower. The spring loaded follower translates along or parallel to the axis of the cam. This is the axis of the cam and axis of the follower, both are parallel. Whereas in the case of figure A, the axis of the cam is normal to the axis of the follower. Okay. Now cylindrical cams is also known as, very important, barrel or drum cams. Okay, barrel or drum cams, very important. Now finally there is another type of cams, that is those are called conjugate cams. Okay, it is a conjugate cam. What is the name of this conjugate cam? A conjugate cam is a double disc cam. It is a double disc cam. Those two discs are being keyed together and are in constant touch with the two rollers of your follower. Now you can see here, there are two rollers are here. And one thing, one roller is in touch, in contact with the another disc. These two followers are not in contact, not in contact with the same disc. There are two double discs are there, one disc with one follower, another disc with another follower. That's why simultaneously you can transfer the motion, that is like a oscillatory motion. But okay, very important is that where it will be preferred, such type of cams, this type of cams are preferred when the requirements are low, when the requirements are low noise and better control of the follower, and in order to transmit high dynamic loads. And very important application of this follower, not application, important advantage of this follower is that it is continuous transmission of the torque from there is no intermittent motion. It is continuous torque can be transmitted in the case of conjugate cams. Now the sixth category of the cams, based on geometry we are studying. The geometry here, it is called globoidal cams. Here the globoidal cams have two types of surfaces. If you understand here, there are two types of surfaces. Here convex and concave, there are two types are here. This is convex and it is a concave surface. But both the convex and concave surfaces are having grooves on their surfaces. Groove is cut. So the application of this type of cams are very limited to moderate speeds, and where the angle of oscillations of the follower is large. Here, in the case of these followers, the cylinder, the globoidal cams, the cam will always under rotary motion, but the follower motion, the driven member motion is oscillatory motion. Like in the case of simple pendulum, it is an oscillatory motion. To and fro motions, oscillatory motion. Next, finally, seventh one is a spherical cams. We can see the spherical cam in the figure. So the spherical cam is completely sphere. The sphere is completely, the groove is made, cut on the surface of the sphere, and here it is a roller type. The roller of the follower, what will happen? If you want to transfer the circular motion of the sphere, what will happen? It is up and down motion, radially it goes. So the driver member is the spherical cam, and the driven follower is the oscillation. Follower oscillates. So very important. These 7 types comes under the category of the cams based on the geometry. Cams based on the geometry. So these are the different types, different classification. First classification of the cams. So second category, according to the follower movement. This is category 1, second category. Based on the second category, what is the follower movement? So the motions of the followers, as we have discussed more and more before classes, number of times we have discussed. Here, if you understand, the follower movement can be uniform velocity or uniform acceleration or uniform retardation or simple harmonic motion. So here the followers are described. Here the motions of the followers are distinguished from each other by the dwells they have. What is this dwell? A dwell is the word is a zero displacement or the absence of the motion of the follower during the motion of the cam. Let me explain. Suppose it is a cam is a circular arc cam. Circular. It is a radius remains constant. It is connected with a knife edge follower. When this cam is rotating, what is the motion of the follower? What is the motion? The motion of the follower means it cannot be translatory motion. Vertical translatory motion for this follower is 0. Why? The radius of the cam remains constant. That means there is no displacement in follower. 0 displacement. That means that 0 displacement or absence of the motion of the follower, that angle, what is that angle here? 360 degree completely. Here the 360 degree of the cam is a dwell, completely dwell portion, dwell angle. This 360 degree is called a dwell angle, and the motion of the follower is 0. That means in dwell position. That is the term dwell. Dwell in dictionary meaning is called staying at one place, dwelling. Okay. Now it is a dwell. Suppose if the cam is changed the shape, now it is not constant radius. There are different radius, but this portion remains constant radius. Okay. But here this portion is different, theta rise. Okay. Now these portions what will happen? cam will rise and cam will fall down. But whereas in this portion of the cam, the follower doesn't move. It remains zero displacement. It is having zero displacement. So this angle is called dwell angle. Okay. Thus, we can define and we can understand what is dwell. Now, based on the classification of the follower motion, rise, return, rise. This is triple R. Triple R means here it is not a movie name. Okay, it is a rise, return, and rise. In this case, what will happen? During the rotation of the cam angle, it will rise and it will return. Okay, again it will rise. There is no dwell. Whereas the figure you can see here, in the case of figure B, there is a dwell starting portion, dwell, there is a rise, and again dwelling and return. What is rise and all here? Suppose rise and return means the follower, the cam will be in different shape. For this, dwell, rise, return, DRDL, this is called DRD, dwell, rise, dwell, return. So here the dwell remains constant, that is another. Now the third, DRD means DRD, dwell, rise, dwell, return, and dwell. If we observe 1 to 3 categories, in first category there is no dwell. Second category, 2 dwells are there. Third category, DRD, 3 dwells are there. So 0 dwell, that is second category is single dwell, 2 dwells, and third category is 3 dwells. So this is also we can dwell. Thus, what is the dwelling, as I told you, based on that. Okay, that is 2 classifications we have studied in this class. Now, in third category of the types of cams, we'll study in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.